Hello, I'm Sue Nelson on a beach in Swansea Bay for the Planet Earth podcast. You can probably hear those seagulls. This crunch are the shells beneath my feet, and there is a road just in the background. That's how close we are to the main town, so you can hear the gentle hum of traffic there as well as the birds. And the reason I'm here is because lurking in the waters off the Welsh coast are thousands of barrel-sized barrel jellyfish, and scientists want to know an awful lot more about them. We'll find out why and how they go about it in just a moment. And it may be a cold, damp autumn day here, but we'll also be trying out a super cool experiment.
So you can now see it.
That's amazing! It's turning to slushy ice in almost a pyramid shape as you pour it.
Fell over.
Back to the beach now, which is just walking distance from Swansea University and a perfect location for a marine biologist, in particular Dr. Victoria Hobson, who's with me now. Now, Victoria, I mentioned these barrel jellyfish. They're among the biggest found in British waters. I've already called them barrel size, so can you give us a little bit more detail about these jellyfish?
Yes, certainly. They're about 30 kilos in weight, and if you can imagine, the fully sized adults, fully grown, are about the size of a black dustbin that you might put your rubbish in on your drive or out for the binman.
That's enormous. So, sort of what colour are they?
They're a sort of a milky white colour, fairly opaque. They feel a bit like gristle that you might find in your in a bad bit of meat, and they have this pretty purple frill just edging the top of the umbrella or the bell.
Do you have any idea of how many are lurking close to this coast?
I think thousands, possibly millions, depending on the time of year and the quality of the environment that they're in.
Now, Swansea University is part of a 4-year eco-gel project designed to shed light on this particular jellyfish. What do we know about them so far?
Unfortunately, the problem is that we don't know very much about these jellyfish. Everyone recognises a jellyfish, everyone can identify it, but the natural history of jellyfish is very understudied. So we're trying to find out things like where they go, what they do, how long they live for. We don't know the life of how long these animals can survive.
You say where they go. Does that mean that they're not in these Welsh waters all year round?
Well, we don't know. We certainly know they turn up in the summers, but over the winter we don't know whether they're able to survive a winter or whether they disappear to deeper waters maybe, or they go further offshore. We just don't know where they go.
So how are you going to find out then where they do go?
Well, we've been starting with things. We do aerial surveys to look at the distribution of the jellyfish around the UK waters and when and where they might be at certain times of the year.
Is this because they're so large that you can actually see them from the air?
They are so big we can see them from the air. You can see them, the bells actually pulsing and them swimming along from the air. We fly at 500 foot, about 150 metres, and they are very clearly visible from that height and higher if you need to. So we can spot them from the plane, and we look at distribution maps. We also do boat surveys from things like ferries that cross between here and Ireland and from small research vessels. We do net tows from big research vessels as well, looking at the distributions in the water columns. And recently we started tagging jellyfish. Firstly, we've done it with these tiny dive computers which measure the depth and the temperature of the water that the jellyfish is in. So we can look at their vertical movements in the water column, and we can see from that a little bit more information about whether they move out into deeper waters. And the future is to look with GPS tags and to see whether we can find out where they go that way.
GPS sounds interesting. How can I see a little bit more about this particular aspect of them?
Well, if we pop back into the lab in the university, and I can show you the tags that we use.
Excellent. Well, while Victoria and I leave the beach and head towards Swansea University, just a couple of 100 metres away, here's an easy science question for the pub quiz. What temperature does water freeze? An easy one, you're probably thinking. 0 degrees, of course, but not necessarily. Scientists at the University of Leeds believe supercooled water may be implicated in the crash landing of a British Airways 777 at Heathrow in 2008, when both engines lost power. Richard Hollingham met Ben Murray at his lab in Leeds for a demonstration.
So we've just got a chilled bath. It's at minus 7 degrees C right now, and in that chilled bath I've got some bottles of bog standard mineral water.
So we can see on the top that it's -7, and you look in, these aren't frozen.
The water in these bottles is actually at minus 7 degrees C. but it's not frozen. So I like
Hang
to
on,
ask...
that's wrong, isn't it? Because doesn't water freeze at 0?
Well, I actually ask my students that question. They often look at me a little quizzically and say, well, 0 degrees C, of course. I have to tell them that isn't actually correct. Ice melts at 0 degrees C, yes, but water does not necessarily freeze at 0 degrees C. And this is quite a nice demonstration of that. Water can exist in a what's called a supercooled state, so it can exist below 0 degrees C in a liquid form. In order to turn it into ice, you have to have the right type of particle or the right surface present to catalyse the ice nucleation process or the ice formation process.
So ice will only form if you've got something in it, some sort of particle or something that triggers it to become ice.
Absolutely, and it has to be the right type of particle. This is water in bottles, in plastic bottles. Clearly those plastic bottles do not provide the correct type of surface to catalyse the freezing process. As people know, if water falls on the ground outside and it's below 0 degrees C, it tends to freeze. So out in the environment, there's lots of things that can actually cause freezing.
So this is water, let's get this straight, water at, according to this digital thermometer on here, -7.
Yep, absolutely.
So what are you going to do to it?
We're just going to take a bottle out. In fact, I'll do that now. That bottle should be at -7, and you can see some condensation, a little bit of frost on the outside. And as you can see, it looks like liquid water. It's moving around in the bottle.
I just feel that, yeah, it's definitely cold.
And now what I'm going to do is just pour it onto this tray, onto this glass dish. There's a little bit of ice in that glass dish, which should trigger the crystallization. Now if I just pour this out carefully... Okay, there it goes. So you can now see it.
That's amazing! It's turning to slushy ice in almost a pyramid shape as you pour it.
Fell over.
Instant ice.
Absolutely, yeah. So the supercooled water, as soon as it hits something it can freeze on, it does so. And you can hear it sloshing a little bit there. Oh, it's going to overflow. There it goes.
So there we go. You poured a bottle of water onto a dish, and as you poured it, it became ice.
I tell you, just to prove there's nothing funny going on. We can just eat a little bit of it.
Okay, can I try that? So this is not. Wasn't some chemical.
Yeah.
Yep.
Just cold.
It's cold. It's definitely ice. I'll put rather too much in my mouth then. It's quite a vivid demonstration. It's instant as well. There was no slow freezing process. It was.
Of course. Yeah.
Well, you say, of course. Now, you've done this many times as an experiment. You study ice and this supercooled water in clouds, but you made the connection between what we've just seen demonstrated here and the plane crash in 2008 when the Boeing 777 crash landed short of the runway at Heathrow.
I was actually made aware of this issue by a colleague called John Morris. He's a small company down in Cambridge. He made me aware that it was something to do with ice in the fuel system that was apparently caused this fuel blockage, which caused the plane to lose power as it was approaching the runway, which obviously caused it to crash land. In the crash investigation report, the official report on the accident, the engineers implicitly assumed that water droplets below 0 degrees C existed as ice. And then they went on to describe experiments they'd done where they noticed these apparent ice particles became sticky at about -8 degrees C. We read this report and we just thought, hang on. First of all, water doesn't freeze at 0 degrees C. Water droplets will exist and stay liquid right down to much lower temperatures. And what's probably happening in that fuel system is that water droplets are hitting surfaces and then freezing when they collide on those surfaces. So we just set about using our existing equipment that we use for atmospheric cloud research to show that water droplets suspended in jet fuel are actually super cool. And that's what we demonstrated. In fact, the water droplets suspended in this jet fuel only froze at about -36, -37 degrees C. So the jet fuel doesn't catalyse the freezing process.
So in jet fuel, you assume then that in jet fuel, with planes flying above us now, there is this supercooled water in there?
Yes. I'm obviously not an expert in aviation and jet engine fuel systems, but yes, you would expect at the low temperatures that planes fly at, that some of the water in the fuel system will exist in a supercooled state, and then when it collides with surfaces, it can then freeze. I still fly. I don't think this is a major problem. It's only happened a handful of times, but it has happened a handful of times, and I think it is important to get to the bottom of it.
Ben Murray talking to Richard Hollingham about the impact of supercooled water. And if you want to see that experiment for yourself, you can watch a video on the Planet Earth website. Well, I've left the beach just in time because it started to rain, and I'm in a much drier and warmer area now. Having said that, as you can probably hear from that dripping water in the background, it's equally as wet because I am inside the Swansea University School of Environment and Society's aquarium with marine biologist Victoria Hobson, who promised to show me one of her GPS tags that's going to be put on the barrel jellyfish. And indeed, you do have a selection of what look quite odd objects. That's the only way to describe it. It looked like fishing wire and a couple of objects that you're just going to have to explain what they are. All I can say is that two of them are very bright orange.
Yeah, well, I have a few things here. One of them's the GPS tag itself, which collects the location data that the jellyfish is at.
And this is tiny, isn't it? It's only
about the size
a matchbox.
Yeah, that's exactly how I describe it. And this can log the data and the time for about 10 days of where a jellyfish has been every 5 to 10 seconds, so we can get a really good resolution of their movements.
How do you attach that? I mean, that is so smooth and white, like a little electronic matchbox, but I don't see any way to attach that to a gristly, rubbery jellyfish.
Well, the matchbox goes on top of a float which I've made, which has got it's a sort of a foam with microbubbles. It's neutrally buoyant, so it sits just on the surface of the water, and the GPS is attached to the surface of that float.
So
and it
this
looks a bit
orange
like a
float,
cone. It's the shape of a sort of a cone,
or
upside down.
An Apollo 11 space capsule upside
exactly.
down. Yeah.
And that's this bright orange, and the GPS sits right on top of that, as you can't get a GPS signal through water. So in order to find out where they go, we do need the tag to be on the surface of the water. So the GPS tag is attached to this sort of re-entry capsule type float, which sits upside down and is attached to the fishing wire, which is
So it is fishing wire.
It is fishing wire. It is exactly fishing wire. It's very heavy gauge fishing wire, so it can't knot itself. The very fine stuff can knot itself when it's underwater, and if you have it out on a length. This is quite tricky to knot, and we unravel this. It's attached to a sort of a crabbing line reel at the moment, and we unravel that, and we attach that through with a cable tie to the sort of the trunk of the jellyfish. So if you imagine the jellyfish look like a tree, you've got the bell on the top, which is like the leaves, and you have the trunk, and then the tentacles, which are like the roots. So if you attach something around that trunk, it can't slide off up and down, and because it's like gristle, you can't really, these jellyfish are so robust, you can't rip them or snag them, so these cable ties just sit loosely around there, and the jellyfish can move about, and the tag follows them and lets us know where it's been.
So it's, in fact, a very simple idea, a combination of simple fishing expertise with GPS technology.
Exactly, there's nothing complicated about it. We just need to have to recover the tag in order to get the data.
In terms of getting the data, though, have you trialled this so far, and how successful has it been?
We've done some trials this summer in Carmarthen Bay, just around the corner from Swansea, and we've tried it on, I think it was 6 or 7 jellyfish at the time, and we've got data from those movements.
And why is it important to know the location of all these barrel jellyfish?
Well, one thing we want to know is whether they can stay in these particular bays that we find them in around the UK, as they're prey of a critically endangered species that visits the UK waters, the leatherback turtle. So we want to find out whether the leatherback turtles come here and whether these jellyfish are always here or whether they can move further offshore. It's also important to know for impacts on things like fisheries. These jellyfish eat the larvae of fish and shellfish, and we've had problems with recruitment of particular species like cockles in Bury Inlet, which is just on Carmarthen Bay, and we're trying to find out whether that's related to the jellyfish and whether they're eating them. So if we know where they are, we can start to look at their impacts. And then there's the health risks for tourism, and if we know where these jellyfish are, we can arrange beach closures, or we can warn people about swimming in the sea and the risks they might face.
Dr. Victoria Hobson, thank you very much, and we'll keep you updated about the jellyfish tagging project in future editions of the Planet Earth podcast. And you can also check up on our Facebook page and the website. And I think that running water is having a slight effect. So before I go to meet Tamara Jones from the Natural Environment Research Council, I think I'll take a break. That's better. We're in a much quieter lab across the hallway there. Now, I mentioned the website, which is an extremely useful source of news from the natural world, as is Tamara Jones, of course, from the Planet Earth online team. And she's joined me with details first of a new fish species.
That's right. Well, there's an international team of marine biologists. They've just returned from the Southeast Pacific. They went to the Peru-Chile Trench and they found a brand new species of fish. And what's amazing is that, we're talking like 8,000 metres deep, which is loads of pressure. Scientists just didn't even think there would be life at that sort of depth.
So what does this life look like then?
It's this thing called a snailfish, and it's white. It doesn't look anything like a snail, unfortunately. You can see pictures of the fish on the Planet Earth Online website. But what's really amazing about this trench and these fish is that it's not just a couple of fish, loads of fish, really complex ecosystems. And what's really incredible is that the scientists are starting to realise that each trench has its own unique ecosystem.
So it's like a whole new raft of underwater worlds, sort of waiting for marine biologists to sort of get stuck in and explore them effectively.
Yeah, absolutely. Yeah, exactly.
Now, you mentioned that the pictures of these fish, snailfish, but don't look like snails, are on the Planet Earth Online website. So what else is attracting attention on the site?
There's a video of some footage of inside something called the Red Zone in a town in Italy that got hit by an earthquake last year, 6th of April 2009. Massive earthquake, 6.3 magnitude. It killed 308 people and it's displaced 65,000 people out of their homes. And the video really is to show the damage to the buildings and just to sort of really highlight the fact that it's a complete mess and it needs attention, something needs to happen. The video is really to highlight to the authorities and to geologists, etc., what now? What are these people going to do? How to get back to their homes?
An up-to-date news flash now, finally, about Romans.
We're talking about headless Romans in a cemetery in York. Some archaeologists decided to look at their skeletons. I mean, some of them were headless, some of them weren't. So they decided, well, where did these Romans come from? Were they local? Were they Yorkshiremen? Were they from abroad? They had no idea. And the way they can find out is they can look at their skeletons, they can look at the bone, and they can look at the teeth and the ones that did still have their heads to figure out where they came from. If they look at the isotopes in these bones and teeth, because isotopes are different versions of the same chemical element and they're distributed variably around the world. And if you look at the different sort of concentrations of these isotopes in the teeth and bones, you can figure out basically where somebody grew up. Their research showed that some of these skeletons look like they came from, or some of these Romans look like they came from as far away as Eastern Europe, which, they just didn't expect at all.
So it sounds like the uncovering of a mystery where more people are going to have to now look into where these people came from and why.
Exactly. It kind of opens up more questions, really, as often is the case with science.
It is indeed. And certainly with the Planet Earth podcast, of course, which you can not only get online from the website, but also from iTunes. My thanks to Tamara Jones, Victoria Hobson, and from me in Swansea, goodbye.